Okay, we've got a good number online now, so we'll make a start right away. So good morning everyone. Thank you for taking the time to join us today. My name's Dave Bennett. I'm your host for today's webinar. I'm joined today by Abby Hunt. Abby is KOREC's Mapping and GIS Sales Consultant for the Eastern region. Abby's background includes 10 years working as an archaeological investigator for English Heritage. She was able to put her MA in landscape archaeology to good use, and she specialised in landscape surveys, surveying archaeological earthwork sites with GPS and total stations, and Abby was also heavily involved in English Heritage in developing the use of integrated GIS and bringing in mapping grade GPS for recording within the team. So I'm going to start by just taking you through some of the commonly asked questions, and then I'll hand you over to the business end where Abby will be taking you through the rest of the presentation. Okay, so our webinars are recorded, and then we upload them to the KOREC website for viewing after the presentation. Please ask as many questions as you'd like throughout today's webinar. You can do that using the question pane. We tend to lock down the phone lines just to save on any background noise. I'll collate the questions during the presentation, and then we'll deal with those as many of those as we can once we get to the end of Abby's presentation this morning. So the question pane, quite simply, is a messenger system. You can type your questions for us, and that way, as I say, we avoid the background noise that can arise. So when you look at the question pane, simply type the questions into the question panel, click send. I'll collate those questions, and we can get through them in the Q&A session, which we'll have at the end of the presentation. So without any more delay from me, I'm going to pass you over to Abby, and she'll talk you through about how mobile data collection and the value that intelligence and knowledge from that information can, what kind of value that can bring to your own working environment. Abby.
Thanks, Dave. Good morning, everyone. As Dave said, I'm Abby, and I'll be presenting today's webinar. So the aim of this session is to give an introductory overview of data collection and management and the Trimble handheld mapping devices and software that are available to achieve that. In outline, the structure of the session will be as shown on your screen now. So we'll start with a general overview of GIS and its role, followed by a look at some of the Trimble hardware available and the software which can run on it. We'll then look at some situations where this technology has already been rolled out before demonstrating the simple steps involved in the creation of a data collection form. And as Dave has mentioned, if you do have any questions as I take you through the presentation, please feel free to submit a question via the on-screen question pane. Over the past few years, the crucial role of GI, or geographic information, has developed rapidly, and it's now a widespread expectation of customers and clients to have access to accurate and informative positional information. The list on screen shows just a few of the ways in which people are increasingly expecting to access this type of data. Behind this front end, there are a growing number of industries which are adopting the use of GIS, geographic information systems, as a powerful tool to manage their assets, to simplify workflows, and to ensure that data provided to customers and clients is reliable, accurate, and fit for purpose. The concepts underpinning GIS are not new. People have been collecting data by writing information on paper and drawing up maps for centuries. However, bringing them together in a digital environment has vastly improved the versatility and integrity of data sets which have a geographic location element to them and have increased efficiency in data management. GIS is commonly used in the sectors shown on screen at the moment to good effect, ranging from estate management through to environmental agencies, archaeology, and utilities companies. The use of GIS basically means that businesses and organisations can access rich data sets for their assets or features of interest at the click of a button. So why good data? Whichever sector we're looking at, for a GIS-based workflow to be optimized, it's necessary to input good data. Good data will, in short, lead to savings in time, effort, and cost. If you're collecting data which is accurately positioned with clear and consistent attributes attached, and back office staff will not have to spend time verifying locations and cross-checking any attached information. Also, if your field workers are presented with a comprehensive list of options as they're recording or monitoring the asset, then you can be guaranteed that they will all be using a standard set of definitions or measures. So by using consistent terminology and spelling through the standardization of the data input options at the point of collection, the downloaded data will be ready for incorporation into an existing GIS with minimal data cleansing. Or if you're starting to build a GIS from scratch, then it will be high quality data which will form a reliable baseline data set. All of this means that if you can be confident in recording the information you need in the field efficiently and accurately first time, then you'll be minimizing the time needed subsequently for editing and verifying that data and reducing the need for costly return visits to sites for repeat data collection. So, how can you ensure that data collected in the field is good data? Well, an important aspect of the collection of geographic information for use in the GIS is GPS, Global Positioning System technology. By using satellite technology to record the location of assets or features, it is possible to get a reliably accurate position instantly. People often ask, can't I just use my phone or my sat-nav to locate the features I want to record? The answer is yes, you could, but the accuracy that you get would be around 10 to 15 meters at best, so the data wouldn't be positioned precisely enough for most mapping requirements. And this is where the Trimble range of handheld mapping devices comes in. They all use both GPS and SBAS, the satellite-based augmentation system, which in the UK and Europe means access to the data from EGNOS, the European Geostationary Navigation Overlay System, to provide accurate positioning. It's this technology which sets the Trimble devices apart from the off-the-shelf sat-navs and smartphones and guarantees accuracies of at least 5 meters and with certain configurations that can be taken down to a matter of centimeters. So at KOREC, we supply a range of Trimble GPS mapping products which can provide accurately mapped information for integration into new or existing GISs. The product range is extensive, and as I've mentioned, we can now offer accuracies from 5 meters right down to centimeter accuracy. With the various types of software available for these devices, it's possible to record not just the position of an asset, feature or incident, but also to record attached information, whether that's in the form of text or a photograph, ensuring that a solution that is fit for purpose. Wireless connectivity across the range also means that data can be transferred from the field without the need to physically return to the office. All of the solutions we offer are completely adaptable for any project and are backed up by expert staff who are on hand to provide consultancy, advice and technical support at every step of the way. And of course, in the field of mapping GIS, Trimble are the market leaders. So in terms of the software, the Trimble mapping GIS range will all run a variety of Trimble software or third-party softwares, enabling you to deploy Trimble handheld devices within a pre-existing setup and to complement established workflows. So as well as Trimble's own software, the devices can also run Esri's ArcPad software and some of the more widely used third-party asset management software packages, such as Simology, Confirm, particularly the Highways module, CADCore, and Mayrise. And it's also possible to run any application which can receive a NEMA output on the devices as well. So with regard to the products, we'll be focusing today on those on the left of the image, the Juno 3 series and the Juno 5 series, our entry-level products, which may be compact, but certainly not small on features and productivity. Let's look first at the Juno 3 series. So this is an entry-level unit which can offer a good positional accuracy with straightforward operating procedures. As you can see, there are 2 different models, the B and the D. The principal difference between them is that the D has a cellular modem, which basically means it can also be used as a mobile phone by inserting a SIM card and to wirelessly transfer data via mobile phone networks. The D also has a flash with its integrated camera. Otherwise, as you can see, both models offer an accuracy of 2 to 5 meters in real time, so this is what can realistically be achieved in the field. Providing the data is captured in the right format, there's also the potential to post-process it, which means downloading the data and relating it to a network of known points for example the OS base station network, to increase the precision. So with the Juno 3, this would mean positional information accurate to 1 to 2 meters. Onboard data storage of 2 gigabytes means that there is plenty of space to store recorded data and background mapping or imagery, with the option of adding a micro SD card to increase the storage capability. The integrated 5 megapixel camera means this is really an all-in-one solution, as there's no need to carry a separate camera, as good quality images can be captured at the point of data collection, and of course will be geotagged and associated with the relevant field data immediately, which reduces the risk of photographs and attributes becoming separated and vital information being lost. The 3D additional mobile phone capability has the added benefit of ensuring that field workers are able to keep in touch with the office and is a useful feature in terms of health and safety requirements. In terms of the practicalities of the 3 series, the unit offers good battery life. It will give at least 10 hours of continuous usage, and that's with the backlight and the GPS on. Its size is also a big plus point. It's fairly light and can easily be slipped into a pocket. And it's much more user-friendly than having to take a separate notebook, pencil, mobile phone, camera and paper map out into the field. The screen is actually a sunlight-readable touchscreen, and it can be operated by with a stylus, which is integrated into the unit. It also has Bluetooth and wireless connectivity, so it's possible to use the Juno 3 series to access online mapping and imagery, as well as transferring data directly back to the office from the field where Wi-Fi is available. And with the 3D, this can obviously also be done where Wi-Fi is not available, as the mobile phone function can be used to send and access data via the mobile network. It can also be configured to receive emails and access the internet, ensuring that field workers are always in touch and able to respond to issues quickly. These devices are robust. They have an IP rating of 54. In real terms, this means they're protected against dust and splashing water or wind-driven rain, making them suitable for working in relatively inhospitable locations and varied conditions. Given the current weather we're having, I think that's a very, very good plus point. With prices starting from a little over £600, this is an ideal unit for deploying across a large workforce to gather good, reliable data efficiently. So building on the success and popularity of the Juno 3 series, Trimble have recently introduced the Juno 5 series to the mapping GIS range. This is a smartphone-inspired super rugged device which will bring the Juno range to a whole new market. I think the growing number of people using smartphones mean that the form of this device will be familiar to many, and there'll be a comfortable working environment for a lot of people. Like the 3 series, there are 2 models of the 5 series available. The difference again being the ability to use the 5D as a mobile phone and for data transfer over the mobile phone network. In terms of accuracy, the 5 series offers an accuracy of 2 to 4 meters using satellite signals from the GPS satellite and EGNOS. There's a large amount of onboard storage, up to 16 gigabytes on the 5D, and this can be augmented with the use of a micro SD card up to 32 gigabytes. So even if you're using, for example, aerial imagery as a background for mapping against, then the device has plenty of memory to cope with large files such as these. The camera is an impressive 8 megapixels with a flash on both models, ensuring that photographs taken with the devices and attached to records are of high quality. As with the 3 series, the photos are geotagged and linked immediately to the record they are associated with. The Juno 5 series is also suitable for all-day working, with a battery life of at least 8 hours, with the GPS and backlight on, and up to 14 hours at low power. It is slightly heavier than the 3 series model due to the greater ruggedization, but can still be fitted into a pocket. The screen on this device is 4.3 inches, and it's a touch screen made from Gorilla Glass, which basically means it's increased in resistance to damage and scratches. The device is, like many smartphones, operated by touching the screen, but it is possible to purchase a capacitive stylus if required. So although it looks like a smartphone, the Juno 5 series is a much more rugged proposition. It has an IP rating of 65, so it's totally dust-proof and resistant to heavy wind-driven rain. It will also survive a 4-foot drop. So it's clearly a device which will withstand working in even the harshest of conditions, and will present savings in terms of minimising repair and replacement costs due to wear and tear. Prices for this new Juno 5 start from just over £1,000. And currently the Juno 5 series comes with Windows embedded handheld operating system, but the 5D model will also soon be available with an Android operating system. So why use these products? We've looked at the features, but what are the benefits of the products? Well, in summary, they can offer very real savings and efficiencies. Traditionally, data collection has been carried out using pencil and paper. Field workers might typically go out and collect data into a notebook, sketch a location onto a paper copy of a map, perhaps take a photograph with a digital camera, and then return to the office. Once back in the office, the data would be entered into a spreadsheet or GIS, possibly by a different member of staff even, and photos and grid references would have to be associated with records manually. Throughout this process, there are numerous opportunities for errors to creep in or for pieces of paper to be mislaid, and errors such as these can cost time and money. With the collection of data on a handheld GPS device, all the components of the record are collected at the same time and securely stored until they're downloaded or transferred, reducing any risk of photographs, attributes, location information becoming separated from each other. Parameters can be set prior to working in the field, making sure that data input is consistent and standardized. Good data also means less time and money spent on cleansing data and making it compatible with existing GISs. Field workers can maximize their time in the field as they're only carrying one device, which speeds up the time spent recording each asset or feature and allows them to cover more ground as a result. In order to illustrate the types of practical applications of the Trimble Junos along with data collection software, I'd like to use this example. The background to this story is that Birmingham City Council, in partnership with Amy, needed to know the location of all the trees associated with the highways across their area of jurisdiction with an accuracy of 2 to 3 metres. PBA Consulting were contracted to undertake this work and chose the Trimble Junos to gather data. Positional and attribute information was required for every tree so that an accurate and up-to-date database of the tree stock could be compiled. This resulted in 76,000 trees being recorded, and bearing in mind that each tree required 20 to 30 taps on the screen to input the information, that's a huge 2 million screen taps across the project. Despite this, all 9 units we used were still fully functional at the completion of the work. The information was recorded using FastMap mobile software as it was straightforward to use and allowed the flexibility that PBA Consulting required, with the ability to create in-house forms for the data entry. Once collected, the data was downloaded as a CSV file and imported into the Confirm software that the Highways Service used. To give you an idea of the types of data recorded, it wasn't just basic information such as tree species and condition that was recorded, but also more complex information such as the proximity to power lines and properties. All types of data can be captured using the software's customization functions. So in summary, this is an example of the deployment of Trimble Junos as a cost-effective solution which provided results well within the specified accuracy. The reliability and robust nature of the devices meant that the project ran to time and that there was very little downtime, whilst the software worked with the Council's existing system and allowed customization of the data collection forms to suit the task and to return all the required information. Further afield from this, Trimble Junos have been used on a huge variety of projects, from mapping bushfires to recording land ownership information and undertaking tree inspections in locations as diverse as Australia, Ecuador and China, demonstrating just how versatile they are. I'd like to now look at a bit more of a practical aspect of data collection. I've already touched on the software that's available for use on these devices, but we'll now focus on one aspect in a bit more detail. To demonstrate how straightforward it is to get started with data collection on the Trimble Juno, or indeed any of the other mapping devices in the range, I'll now demonstrate how to create a data collection form which might otherwise have been created and filled in using paper and pencil. I'll be using the FastMap software, creating a form in workflow which can then be transferred directly to the handheld device where it is accessed through FastMap Mobile. This can also be done through FastMap Dataflow following the same steps. So firstly, within FastMap workflow, I'll start by opening the ATP Attribute Definition Editor window via the feature list here. This brings up the ATP editor icon, which you can see circled in red there. Clicking on this then opens the ATP editor window. In the ATP editor, I can add as many fields as I wish by using the Add button. And as you can see, on the right-hand side of the screen there, a new field has been added and is highlighted in red. So this can be renamed by over-typing the field name to the left, which at the moment says New Field. You can name it whatever you need to enable your field workers to record the right sort of data. The parameters of that data field can be entered using the options on the left. The number of characters in the field can be altered depending on the type of information being input. So for example, if you had a specific ID number which you needed to limit to a certain number of characters, you can ensure that everyone was putting in the right number of characters and not going over that. If you want this to be a text field, you can select the type of text from a drop-down list. As you can see, there are many different data formats available, such as date and time, which would automatically be populated. Collection QA is there on the list, which provides quality assurance information about the positional fix of the points. Again, you get a good idea of how accurate your point data is. Further down the list, there's also an option called Hotlink, which enables you to add a photo to the form. And tapping on this field automatically activates the device's camera as in the field. It's also possible to set each field as mandatory or to set it as a hidden field, as you can see at the bottom of the screen there. So that data has to be captured in a mandatory field, so you ensure you're not getting holes in the data that you're collecting. Or you can hide the field, so with the automatically recorded data, the field worker doesn't need necessarily to see the data at the time, but it's automatically recorded within the data that's transmitted back to the office. Other options for the type of data entered into a field list include, which enable you to create your own list of values, include lists, which enables you to create your own list of values, which will appear as options for the field worker. Again, this can be set as a mandatory field, and you also have the option, as you can see at the bottom there, of making the first item in the list as a default value, which would mean, again, if you had a commonly used piece of data, you could have that appearing first, so field workers would merely have to confirm that that was the right case, the right information. Lists can also be nested, which basically means that a secondary list would appear depending on which option you selected from your first list. So again, enabling the data to be broken down into manageable chunks. A field worker can also have a toggle option, whereby two options are input and the field worker can toggle between them. So this is useful when the data to the input will be either one value or another. And another option is the numerical data type, which is suited for information that you want to be read as a number format in a database or GIS. With this option, you can specify the number of decimal places, and there are also other types of numerical data that can be recorded within the data form, including the X and Y coordinates, the elevation or the satellite count. All of these examples will be automatically populated. Once you've created a field to capture the piece of information you need, then click the Add button to add another new field and repeat the process until you have fields for all the items of data you wish to record against a particular feature or asset. So you can add as many fields as you need to the form. If there are more than will fit on the screen of the device, then the editor will automatically create the rest of the fields on a second or third page as required. So as you can see here, we've populated the first page with various data fields, and the next page button is now active. If we click on that button, it then takes us to the second page. So here are two examples from a tree survey data collection form. In this case, the tree species field has been created as a list, as you can see on the screen there. We've got various options to choose from that have been input by the user. So the field worker is limited then to inputting just a choice from this given list. Again, it saves the potential for data sets varying widely and creating problems at the data management stage. The field is also set to mandatory in this case, so something has to be input into the field so that incomplete records are not returned. A useful feature to ensure that complete data sets are compiled and gaps and data aren't left, which always takes time and effort to rectify. On the next page, there is an example of eastings and northings being automatically written into the data form so that these can be viewed with textual information. As well as specifying the data fields, the ATP editor also enables the way that the feature is represented on the mapping device to be set. Everything which is recorded as this feature type, in this case using the feature code tree, will be represented as a small green cross, and this will be a point feature within a GIS. If you wanted to create records of linear assets or features or areas, then the feature type would need to be changed to string or area, but the data fields would still be associated in the same way. Once the ATP has been saved, using the Save and Close button at the top left, will return you to the main workflow window, where the data form that has just been created is now selected. And then, with the mobile device connected to the computer, Send Current ATP to Connected Device is clicked, which transfers the form from the computer to your mapping device. When loaded onto the device, the feature type you have created is selected from a list within FastMap Mobile, and when you record a point of that type, the form is automatically displayed on the screen. As you can see, all the fields that we created in the workflow module are now visible on the device. Drop-down lists are indicated by a downward arrow, you'll see on the right-hand end of the species field, for example. Toggle fields by the check mark. If you go down and look at the urgency field, you'll see there's a different icon at the end there. And the date and time and survey method, the bottom three fields on the first screen, have automatically been populated. Also, on the second screen, note that the easting and northing have been automatically populated. And this happens as soon as the record button is pressed and that data is logged. Once the rest of the information has been filled in and the form completed, then the form can be saved. You'll see in the bottom right of the second screen the save icon. And the point with its attached data is then shown on the screen of the device itself. So in this way, forms can be created to ensure that all field workers are recording data in the same way, with standardized options or automatic data capture, all of which lead to consistent and complete data sets at the end of a day's fieldwork. In this final part of the presentation, I'd like to focus on one particular piece of software which works well in combination with the Trimble Juno and offers straightforward data capture and task management, and that is Trimble Municipal Reporter. This is, in essence, a hosted issue management system which allows contractors to easily record and resolve issues, as well as enabling the supervision of mobile workers. It has a range of applications, but is particularly suited to projects with multiple field workers working across a number of sites, or where office staff need to frequently communicate with field workers regarding work undertaken. Also, in cases where the site is geographically distant from the office location, then the Municipal Reporter system can offer a significant reduction in travel costs when information is transferred wirelessly. The interface is simple and straightforward, with the principal buttons clearly visible on the main screen. It has specifically been developed as an easy-to-use, easy-to-learn field software designed for non-technical field workers. Within the software, viewable maps can be accessed on demand, allowing field workers to instantly locate themselves, plus the device has navigational functionality as well, so field workers can get directions to the next site or instance they need to attend. Similar to the forms that we've just created in FastMap, Municipal Reporter also allows you to create predefined forms for data collection prior to going out in the field. This includes the ability to embed photos in the records as well. The data collected on these forms in the field is delivered wirelessly to the web application, where it can then immediately be accessed by the office staff. The alterations to work packages or new work packages can be created in the office and then sent back to the field worker via the web application. So this is the view of the data being recorded out on site back in the office, which means that office staff have a clear and up-to-the-minute view of exactly what is happening on the site, and decisions can be based on that information. You can have multiple projects running simultaneously and monitor them all through the web application. It is also possible to generate a full range of reports based on the data received by the web application, by team, by week, or by month, for example. And the information collected in the field can be exported from the web application as a spreadsheet or as a shapefile for direct import into a GIS. The software also offers real benefits in terms of fieldworker health and safety. The devices can be configured to update the fieldworker's location at set intervals, which is shown within the web application. This can be done as often as every 30 seconds, so you can monitor location and activity across a number of fieldworkers at a number of different locations. And in the case of an emergency, a field worker can send an alert to the office immediately. So overall, it is a simple to use, cost-effective software package which can bring many benefits to projects with multiple field workers working across diverse locations. So in summary, the Trimble handheld devices offer simple, straightforward operation. You don't need to be an accomplished GIS user to operate the data collection device, and the interfaces are user-friendly and intuitive. GIS managers can ensure consistency of data collection in the field, which can be rapidly integrated into the GIS, and it can all be collected with confidence in the positional accuracy. The Junos can be used with a range of data collection software to suit the task at hand, with many, such as SparkMap Mobile and TerraSync, offering a high degree of customizability. The data collected can be integrated into the vast majority of GIS software, so solutions can be tailored whether you have a pre-existing GIS or not. As an entry-level product, the pricing of the Juno starts at just over £600. A complete standalone data collection system can be achieved from as little as £1,100, and we can offer a complete solution from under £2,000, including one Trimble Juno device and 12 months web hosting. And of course, the ruggedness of the Juno range ensures longevity of the hardware, reducing any replacement costs and general wear and tear expense. So taken together, these factors add up to a cost-effective and time-efficient solution to your data collection and asset management requirements. I hope you found this webinar useful. I'll now answer some of the questions that have come in. But if you want to discuss specific requirements further or to get more details on what has been presented today, then please do get in touch using the inquiry form on the KOREC website, and your local sales consultants will contact you.
Thanks, Abby. Okay, I'm just opening up the question pane here, and we're going to answer a few questions that have come in. Give Abby a chance to have a glass of water as well there, because I think a lot of talking and a dry throat really. So, so I've got a question that's come in here from Josh. If you're using a mapping device with a SIM card, does it have to be on any particular network?
No, the SIM cards aren't network specific. You can use, so if you already have mobile phones amongst your field workers, for example, you can use the SIM card, the network provider that you already use. There's no specific network that you have to use.
Okay, and then we've had a question come in from Robin. Do any of the products have video capabilities?
Yes, there's the option to record in WMV format on some of the devices.
Okay, hopefully that answers your question, Robin. And then we've got a couple more questions. Sometimes field workers have problems in direct sunlight reading the screens. Have you done anything to assist in viewing in sunlight? I mean, without knowing which particular device it is that you're using, Robin, it's difficult to answer to that extent. But I mean, Abby, on the Junos, how do they perform with sunlight?
As I said, the Juno 3 series does have a sunlight readable screen. Also, the screens on the resolution on the new 5 series is very good quality, and when it's backlit, the screen is very much readable in the sunlight. It's a big improvement. I think it's great advances in that sort of technology, which have been incorporated into these devices now.
I guess the simplest way, Robin, is for us to arrange to come and see you and let you have a look at the system working. But, another question that's come in from Sarah. Can you use background imagery, such as maps and aerial photos, with the devices? Yes,
that's absolutely possible. As we mentioned as well, with the data cards that you can add to the devices to increase the memory, You could use raster imagery, aerial photography, LiDAR data, anything like that can be transferred onto the devices. It does depend what software you're using as to what the capabilities are, but certainly ordnance survey mapping can be added into the devices. Basically, whatever you use already, there's usually a way to get that onto the device for you, but certainly raster and vector data can be used, yes.
Okay, thanks very much, Abby. So there's another question from Robin. Are we able to offer client user system software development and integration? I mean, I can answer that one if you want me to, Abby. I mean, yeah, we can, absolutely. And that's, you know, a lot of the success that's come with the adoption of the FastMap software, that's where that's come from. So we do have a professional services team. We have access to a professional services team that we can offer that development work for you. Okay, and then there's one that's come in from Robert. So is the position recorded, easting and northing, the position of where the device is, or where the asset is being recorded is? I.e., if you're recording something in the middle of a road, how do you capture this?
I think what the answer is very carefully. No, the point that you're recording is the point where you're standing, so where the device is. But as I mentioned, if that data, as soon as you press the record button, the data is stored. So if you were then filling in a data form, you could move away and fill in the data form, but still retain that original position. So you do have to stand basically on the asset, around close to the asset, so the unit is where the asset is. If you're recording in the middle of the road, then yeah, that could be tricky in terms of traffic. But certainly, if you were able to capture that data, you could then move out of that location, fill in the data form, and then still save that record with that original position. I hope that sort of answers that one for you.
Okay, and then we've got one more, I think, that's coming from James. To what extent do you find accuracy to improve over time when taking point data with the Juno? Would leaving it for a minute for much more accurate, basically, would leaving it for a minute be much more accurate than leaving it for 10 seconds?
I think whenever you start a project, as the device finds the satellites, and satellites obviously are moving all the time, because the signal is correcting all the time. When you first get out into the field, it'll just a few seconds will get you sort of locked onto the positioning, and then generally within standing on a point for a couple of seconds would take that point accurately. You wouldn't need to stand for a matter of minutes, that's for sure. Yeah, it should give you the position. Yeah, very, very quickly.
Okay. Okay, the questions are coming in thick and fast now, so good. A question from James. Can you record a number of features, i.e. walking a boundary of an agricultural field, to record the field boundary? Can you, whilst walking, record features such as boundary trees without losing the boundary recorded data?
Okay, yeah, I think I see where you're going with that one, James. I think, yes, it's, again, depending on the software, but just as an example, within FastMap, if you're recording an area feature or a linear feature, which your boundary would be, you can obviously start off recording points on that feature, and then as you come to a tree that you wish to record as a point, you simply go to the code selection list, you select the point data, the line or area feature will remain open while you're taking that point, you then record the point, and once that's been recorded, you go back to your feature list and you'll see the feature that you were originally recording, your area or your line, that will still be open, and you can then select that again, and then your next point that you take will be that original boundary feature that you were looking at. So yes, you can change between recording types, and once you've finished that boundary feature, it will then give you the option to close the polygon or the line that you're recording. So yes, that is possible.
Okay, hopefully that answers your question, James. Robert, I see, as you say, thanks for our initial answer. If Abby's unable to answer this one specifically, I think it's probably going to be easier to contact you after the webinar. But kind of following on from Robert's initial question, if you have to manually adjust the position where you're not stood next to the asset, how accurate does this end up? I.e., are you able to move our location manually to a high level of accuracy directly on the device, i.e. live?
you can manually alter the points. You can also manually add points as well on the device. Obviously, the accuracy is then potentially dependent on the background mapping that you're using, for example. And it could be possible to do this sort of transformation in the office once you've got back and downloaded your data. You could make that if you've taken measurements, for example, you could do that. In addition, I mean, if you were, in some various instances, it is possible to link to another device, such as a laser ace rangefinder, which would enable you to take a shot into an area where perhaps you couldn't access on foot, but you could see what you wanted to record. And you could actually build in a data field within your recording form to accept data from an external device, such as a rangefinder. So you could fire a shot into an area that you couldn't access, and that would return the GPS location of the object that you are firing the laser shot at. So again, that would give you the position of the asset rather than where you were standing. Again, that's something you would need to set up within the data form, but that can be done quite simply.
Okay, thank you, Abby. Robert, hopefully that's answered at least some of your question. I think that got to the nub of the issue as far as I'm aware. And then, okay, last question coming from James. Do the on-demand Google Maps rely on a working wireless connection, or can data be cached if you're going to work in remote sites with no Wi-Fi?
Yes, basically the Google Maps function is a wireless connection sort of service. So you would need to initially download those with a wireless connection, but they will be cached. So if you were going to an area, you could preload those, and the map would be available for you when you got to your remote site. Okay, and we had a question about the laser rangefinders. I think it's probably easier if we can email you details of that.
Yeah, David, you've asked a question on the price, so we'll certainly get back to you on that one. We'll have a look at, based on your registration details, it'll either be Abby or one of Abby's colleagues. And Robert, looking at, thanks for your comments as well, Robert. We'll certainly arrange a one-to-one meeting. And Robin, who has also been asking some questions, looks like you two work together, so that's great news. Okay, well, I'm going to thank Abby on everyone's behalf. Thank you, Abby. That's a very good presentation today. Hopefully you've all got something out of that. We do these webinars on a monthly basis because of the range of products and solutions that KOREC provides. It's not always MGIS focused, but there will be another one, and the best way to find out about those is either signing up online to our newsletters or following us on Twitter, or you can find us in the world of Facebook as well. We're just setting up the LinkedIn groups as we speak. So thanks again to everybody for taking the time to join us, and we'll be in touch with those of you that need more follow-up, and enjoy the rest of the snowy weather and the weekend. Thank you.